Hello and welcome to SudoKanard. We're here to solve this little killer Sudoku by Polish author Krystian Świderski. It was featured in the latest Polish Sudoku Qualifier. It was worth 150 points, which is a lot. It was the highest pointer in the round, and it was quite difficult. And you can see that there are very few clues. And I will just remind you of the meaning of those clues. Those numbers are the sums of all digits on the diagonal that is pointed by the arrow. And that's all we have to work with. And on such a puzzle, you need to focus on large sums and small sums. And this 11 is very constrained. It is the sum of 8 digits summing to 11. You know that the digits have to be very small. And if you try the smallest possibility, 1 and 2 in those cells, 1 here, 1 and 2 in those cells, 1 here, 1 and 2 in those cells, then you can see that this minimum scenario gives a sum of 11, which means that this is the only way to achieve this sum. And I will just use some coloring to denote the fact that this has been used to its full potential. And now 20 is a rather small number. 20 with 7 cells, that's an average of 3. And you have to appreciate that most small numbers have been used already. So if you look at the minimum scenario with a 3 here, 2 and 3 here, 3 there, 2 and 3 here, and 3 there, then you get 19. So the minimum scenario is not the real scenario, but you only have 1 degree of freedom, which means that this 3 could be a 4, that this 2 and 3 could be a 2 and 4, but there is a 2 among them. This is not necessarily a 3, but a 3 or a 4. This is 2, 3 or 2, 4. And this is 3 or 4. And likewise, this 18 sum is very constrained because, well, how to explain this? You have 7 digits summing to 18. That's an average around 2.5. And some places already have rather big digits. This is at least 2. This is at least 3. This could be a 2 or something like that. This is at least 3. This here could be a 1. This here could be a 2. This here could be a 1. So 4, 7, 10, 14. So this is not as constrained as the 20 sum was. Now at this point, I thought that those are, I would say, simultaneously constrained. And by this I mean that the digits here put a constraint on this one, this digit put a constraint on this one and this one. So there has to be something global. And I thought, considering this sum is low and this sum is low, I would think that this has to be a 2. And I think such a logical step is the reason why such a puzzle is rated so high, has such a high number of points. What is happening if I try to put the 2 here and not in the intersection of the diagonals with small sums? Well, if I put the 2 here, then I put a 1 there, and the minimum value now for these 2 cells is 3 and 4. And let's just recall that the minimum value before that for those 2 was 2 plus 3. Now we've already surrendered 2 degrees of freedom, where we had 4. This has now a minimum of 2. Here, that's a minimum of 3. Here, because of this one, that's a minimum of 2. And we already have 4, 7, 14. And this can't be a 1 either. So that's a minimum of 2 and 3 here, which is already 17. And it could still be a 1 there. So I've been missing something, I'm afraid. Because I thought that this could not happen. And yes, this could... Oh, I've been missing something here. Yes, I've been missing something here. So I must backtrack here. I've been missing something. So that here, that's a minimum of 2. I said that has to be a minimum of 3 and 4 there. But you have to appreciate that we only have 1 degree of freedom on this diagonal, which means that it's not possible for both those digits to be equal to 4. So one of them at least has to be a 3. And so the minimum value here is with a 4 there. In which case this is a 3. A 3, I said. Like this. That's a 3, and that's a 3. And the minimum value here is a 4 after all. So with a sum of 7 here, the minimum value here will be a 3, and the minimum value here will be a 4. And now because of those ones, the minimum value here becomes 2 plus 3, which is 5, 10, and it's already 18, and this is too much. So that's a very difficult step, I think. Finding that putting a 2 here prevents this diagonal from having a sum as low as 18, which means that on this diagonal, the 2 is here. Well, perhaps such a difficult step was not needed, but this is what I found. And now this 2 gives us the 1, the 2. That's not a 2. This is a 2, that's a 1, and that's a 2. And there again, knowing that at least one of them here has to be a 3, this has a minimum value of 4. And likewise, one of them here at least is a 3, so the minimum value here is a 4 as well. The minimum value here is a 2, so we are already with 12. Here the minimum value is with 1. Here that's a 3, and here that's a 2. And you can see that the minimum scenario gives us a sum of 18 on this diagonal. So that this is 2, this is 4, this is 4, and those are 3s. That's the 1, that's a 3, that's a 2, and we also get the 2 here and the 1 there. And the 18 sum is fulfilled. We are still left with some disambiguation to be made. We know that among those cells, we must have 2 instances of 3 and 1 instance of 4. So that was quite difficult already. And now this one especially is very interesting regarding this 62 sum, because 62 here uses 8 cells. So 8 cells with a sum of 62 makes an average of a little less than 8. But removing the 1, we are left with 7 cells with a sum of 61, which means an average of almost 9. So there must be maximum. Let's try. Let's put 8 and 9 here. Let's put 9 there, 9 there, 9 there, 8 and 9 there. So what is the maximum scenario? 17, 26, 27, 36, 45 plus 17. That's 62. That is 62. So the maximum scenario is the real scenario for this 62 sum. And this will now put some pressure on this 66 sum, I think. Or will it? Well, 66 with 8 cells is close to maximum. What would be the maximum? With a 9 here, the maximum would be 8 here, 9 there, here it will be 8, here it would be 8, here it would be 8, and here it would be with 8 and 9. So the maximum scenario would have 17, 25, 33, 42, 50, 67. So the maximum scenario is not the correct one, but we are very close. We only have 1 degree of freedom. So this here is a 8 or 7. This is 8 or 7. This is 8 or 7. This pair is either 7, 8 or 9, 8. There is a 9, oh, 7, 9 or 8, 9, sorry. And this is also 7, 9 or 8, 9, but there's a 9 here, so this is actually a 9, and this is 7 or 8. And now this 9 does some disambiguation, so there's no 9 here, and that is a 9. It places an 8 there and a 9 there. Sorry about that. And we know that among those cells, among those 5 cells, 4 of them must be an 8 and 1 of them must be a 7. By the way, I've forgotten to do some Sudoku magic, so that's 1. Those ones place and 1 here, and the last one in the grid is there. Let's do the same with 2s. We can place a 2 here. We can place a 2 there. We have all 1s and all 2s. Maybe not as simple with 3s and 4s at this point. Okay, so a lot has been done already. This 19 already has 2 digits placed. So those 2 digits must sum to 9, and there are some big constraints because we can see that all small digits here are unavailable. So this has a minimum of 4, and this has a minimum of 5. So the minimum scenario gives us a sum of 19. So that's a 5, that's a 4, which places a 3 here and a 3 there, which means that the missing 4 on this diagonal is finally here. You can check that the sum is 20 indeed, and 19 here. And we should know more about digit 4 at this point, perhaps not that much more. Let's do some more Sudoku. We have 9s there, so that's a 9. We have 9s there, so that's a 9. And we have all 9s in the grid. And as expected, when dealing with big sums and low sums, we're basically left with placing mid-sized digits between 5 and 7, 5, 6, 7, and 8 also sometimes. Note that 8 will be in one of two positions here. And let us recall that on this diagonal, almost all digits are 8s. One of them here must be an 8. And in both scenarios, this is never an 8. So that 8 goes there in this box. So, only 4 of them at this point. And look at that. With Sudoku, we place an 8 here. So we're left with 3 of them. Okay. So we can see that there's an 8 in here. And because of the same logic, one of them here is an 8. That can't be an 8 anymore. Not sure that this is so useful. Perhaps I should do more with 4s. Oh yes, on this column 4 can't be here, can't be here, can't be here. That's a 4. We have a 4 around here, like this. I'm not sure I can do anything more. All right. So now there's an 8 in here, an 8 there. That doesn't seem to be very useful. So is it the right time to address this 29 clue? Well, this 35 is definitely for the final steps. Is it about the 3s? Oh yes, the 3s. There is a 3 here. There is a 3 around here. Oh, on the last row, 3 must be there. And with all the digits, we can place the 3 here. And we have all of them, I think. And now look at that. With those 4s, I can place the 4 here. And with those, I can place the 4 here. And there. And there. And this 5 goes here. Now let's do some pencil marking, I think. We're mainly left with, we're only left with digits between 5 and 8. For example, we have 6 and 7 here. 5, 6, and 7 in those cells. Also 5, 6, and 7 in those cells. This is 6 or 7. 5, 6, or 7 there. 5 is already here, so... Oh, I've been missing these 3. Sorry. This is now from 6 and 7. 6, 7, 8 here. 6, 7, 8 in there, but let's recall that one of them here is an 8, so this is from 6 and 7. 5, 6, 7 here. This is from 5, 6, 7, 8. That's not really promising. 6, 7, 8 there. So it should probably... Let's have a look at this 35 now that we've penciled out. We already have 10 here, so that those digits should sum to 25. The minimum scenario is with 6, 7, 6, 5, which is 24. That's very interesting. The minimum scenario gives 24 and gives on the whole 34, So we only have 1 degree of freedom, which means that 8 here is impossible, and 7 there is impossible. With this 6, 7 there, we get the 8 here. So there's only 1 degree of freedom, 1, 8 and 1, 7 among those cells. Okay, so here now we need 5 and 8. Perhaps I should have a look at this 29. We have 8 here. So we need another 21. And here the maximum value with 7, 8, and 7 is 22. So here we have 1 degree of freedom from the highest scenario. So this has to be an 8, and this can't be a 5. This 8 disambiguates a lot. So that's the 5. This is 6. This is 7. This is 8. This is 5. This is 6. This is not 6. That's not 6. This is 6. And this is 7. Is there anything more I've been missing? This 5 now goes here. That's a 7. That's a 5. That's a 5. That's a 5. That's not a 5. Here, this is from 7. Oh, there's a 7 here. So this is 8. This is 7. This is 8. This is 6. This is 7. This is 6. 7, 6, 7. 6, 7. Yes, I'm saying 6, 7 a lot. I know. And that's a 5. And this is it. So with this 8 here, we've just disambiguated the whole lot. And I haven't checked, so let's check here. We have 22, 24 plus 11. That's 35. Here we have only 1, 7, which was the goal. Here we have 10, 18, 22, 29. This is correct. Yes, the fireworks were there for a reason. Okay, so that was a pretty difficult puzzle. I'm not sure that my step with the 2 was the intended solving path, but I mean, it works. It works. And it's really not easy to see. If I had to take the test to do this in the allotted time, I think I wouldn't have been able to complete the whole round. So thanks for watching this video. Thanks Krystian Świderski for this remarkable puzzle. See you sometime on SudoKanard.